All right, good afternoon. You can't tell me that you guys are all here to listen to a talk about cybersecurity, so it must be the free beer that's shortly after this talk. But either way, thanks for being here. Real quick before I get into this talk, how many people here are familiar with the concept of offensive security or red teaming? A couple? Okay, about half the room. So for those of you that aren't, it's where you use ethical hackers or adversaries to enumerate vulnerabilities in the system, as well as exercise the security apparatus of that organization. So, quick overview of what I'm going to talk about today. I'm going to give a background on my company and myself because I assume you're unfamiliar with a cybersecurity company from Maryland. We'll talk about cyber warfare in space, the state of cyber and space today, threats and vectors to space systems, and what tomorrow's going to look like. So not to grandstand, but again to give a frame of reference for the rest of this talk, 6Gen is a disabled veteran-owned small business out of Annapolis, Maryland that primarily does DoD certified red teaming, incident response, and high-tech, high-risk system vulnerability analysis. Locally, there's a few of us. We do space systems engineering, program integration, and cybersecurity. I'm local here in Huntsville. I have 14 years of experience in offensive security. I did it as a Marine and a contractor for the DoD, and I later did adversary emulation for Fortune 500 commercial clients as an ethical hacker. I've written a couple books on cybersecurity, red teaming, and cyber warfare, and I'm currently writing one about cybersecurity for space systems. So if you're interested in what I'm talking about today, feel free to help put my kids through college and buy a copy later this year. Currently, I do cybersecurity advising for a government customer on security strategy and integration. And one disclaimer before we get into anything else, I have never hacked a satellite, nor do I have any knowledge of a satellite being hacked. Everything I'm going to talk about today is purely based off the fact that I have a lot of offensive cybersecurity experience and some limited space system knowledge. Some of that was gained. 6Gen had a team. We went to DEF CON. If you're not familiar, it's the biggest international hacker conference held annually in Vegas. They have an IoT hacking competition, and we won that. And I'm sad to tell you all that the systems you all code for kind of bear a striking resemblance to a lot of IoT devices, right? Real-time operating systems, streamlined software, that sort of thing. And space systems are actually really juicy targets. You have IoT-like devices, you have SCADA devices to turn your antennas, you have traditional attack surface in your ground station with PCs and computers, and you communicate over the open air. So as an attacker, I appreciate a target like that. So let's talk about the boogeyman real quick. A little background on cyber warfare, it has a cost-benefit problem. So imagine you're going to fly a rescue mission into an enemy country and you need a radar that is tied to anti-aircraft missiles disabled, right? If you tried to use cyber effects to disable that, it might take a while. You might not actually be able to access that system to disable it. When you execute your attack effect, you can't guarantee that it's going to work the way you wanted it to. I'm sure you are familiar with coding errors. And you can't do battle damage assessment. If I execute a cyber attack against an enemy radar, I don't necessarily have a good way of verifying that it has stopped working. Conversely, if I just blow it up with a missile, I can observe the missile striking the radar, I can see the crater afterwards, and if I'm flying the aircraft over that radar to go rescue people, I'm going to be a lot more comfortable seeing a crater in the earth as opposed to looking at what looks like an intact radar and going, gee, I hope those computer nerds did their job. So that's a problem everywhere but space. So in space, I actually don't want to do kinetic effects if I'm trying to disable something, right? If I hit a satellite with a missile and it's in a very popular orbital plane, I might be making a thousands of mile-an-hour shrapnel net that's going to interfere with potentially my own space vehicles or my allies. So being able to quietly disable or send a space vehicle to burn up in the atmosphere via a cyber attack is actually a much better way of going about that. So unfortunately for you all, the domain in which you code for is the most susceptible to cyber warfare because it's the most relevant. Additionally, any sort of cyber warfare that's going to happen in space, on a space vehicle, is going to be an attack against that vehicle and not for, say, intelligence gathering. If I wanted to see what you're doing with your satellite or alter an image that you took of my country to hide something, I'm just going to do that at your ground station, right? That's a normal computer that's familiar to me as an attacker. I don't need to bother trying to execute code in small communication windows on your space vehicle to prevent that sort of thing from happening. So the only reason I would go through the trouble of gaining remote code execution on a space vehicle would be to disable it or use it to launch attacks at other ground stations or other space vehicles. Tying all this together, I think we can all agree that almost exclusively the actors that are going to conduct cyber warfare or cyber actions against a space vehicle are going to be nation states. So you have the added benefit that the people going after your systems are well-resourced and willing to wait long periods of times to carry out their missions. So what is the state of cyber in space today? Systems on space vehicles are actually at kind of a precarious position. You have, resource constrained, power budgeted, streamlined software running on very limited systems, but the people attacking you have the benefit of modern technology and an internet full of exploits and that sort of thing. It's almost like targeting the internet of 20 years ago via the internet of today, right? So that is another thing that makes me happy as an attacker, that I look at the target set and I go, wow, it's more focused on functionality than security, right? Additionally, some talks earlier in this week talked about the move to Linux and away from real-time operating systems. As that continues to grow, obviously you as developers have the benefit that it's easier to write, drivers and code that are transportable to these systems because they're not custom one-off operating systems. But I'll tell you something, that hackers are developers too, and that means that any backdoors or exploits I write are also going to be more portable to those systems. And it means that as opposed to very unfamiliar computers that I try to attack, it now becomes something much more familiar, right? It looks like any Linux computer I might see connected to a terrestrial network. So another thing that I heard talked about this week is an increase towards software-defined capabilities on space vehicles. I think that's great. That means that I have more things I can use to try to disable your satellite. So if you want to change, software-defined radios, I think, is the perfect example. You go from something that's pretty hardware-based to something that, if I can gain remote code execution on it, I can completely alter the way you communicate, right? So as those capabilities go more software-defined on space vehicles, there's more attack surface there for attackers to go after. There's also more code and attack surface to secure. So next, how many people here are familiar with RMF? Nope, okay. So some of you in the government sector, it's a risk management framework put up by NIST. It's kind of a checklist and the closest thing to test and evaluation cybersecurity has in space. Unfortunately, it's currently not in a good spot. It roughly addresses the difference between a space vehicle and a terrestrial network by calling them out, but it's not really in a good spot to handle securing like a mesh of satellites, right? It doesn't cover what satellite-to-satellite communications might look like, or large sets of geographically diverse ground stations. So that's not that great of a spot, and that's the process the DoD uses to accredit its networks. There's also no widespread regulations for cybersecurity in space, which is kind of a problem. And unfortunately, in my opinion, cyber is not viewed as the highest risk to a space vehicle or its components. And as was mentioned earlier in the week by, I think, one of the MIT talks, right, just because it's not a cyber problem doesn't mean I can't use cyber to introduce it to your space vehicle. So if you use a software-defined capability to prevent something from happening like tumbling, I can then go after that and just make your space vehicle tumble. Or worst case scenario, I can at least prevent your capability from stopping the tumble. So I'm going to talk about threats to space vehicles. These are the ways as an attacker that I'm going to introduce something that's going to disable or damage the space vehicle. There's threats to the vehicle itself, and there's threats to the mission or the payload being run, as well as threats to other space systems and other ground stations. The examples I came up with were based on looking at small sats. That's obviously the most financially and operationally feasible space system currently out there. That's not to say that what I'm going to talk about won't happen on other space systems as well. Additionally, I think it's important to understand that ground stations will be compromised, right? You're not safe because you're on a standalone ground station, and there's not a need for remote code execution vulnerabilities on space vehicle components for me to gain interactive access to those systems. If I can get access to the way you task your payload to do taking pictures, right, I could pass an infected tasking file up to the space vehicle that might get me remote code execution on your payload computer. Certainly, remote code execution vulnerabilities will enable me to do things like pivot around the space vehicle. If you're running things like OpenRTOS or VxWorks that have a lot of vulnerabilities in them, I can use that once I have access to the space vehicle via the payload computer to gain access to other things like the flight computer or the software-defined radio. One more thing before we get into the specific threats. I know that a lot of space vehicles are written with things like watchdog scripts and things like that, that if I tried to attack the satellite and disable something or try to draw down the battery, right, it might go into power saving mode and face the sun and hopefully wake back up. But you have to assume that if I'm executing arbitrary code on any of the competing devices on your space vehicle, I can certainly find those things and disable them. So threats to the vehicle, these are the threats that are specific to the space vehicle itself. Obviously, you have power being the biggest one. If there's no power on your space vehicle, it's not working. That's the most classic way I'm going to go after attacking it. And there's actually a bunch of different ways I can attack power, right? I can say affect the way you generate power. I can affect the efficiency with which you store power. I can affect power budgets. I could say, hey, whatever process, use all the power you want and drain the battery as often as you want, right? So it's not just one way to go against power. It's all the ways that are software-defined controls for generating, storing, and using power. Communication's another threat that's specific to the space vehicle. When we're talking about communication, it's if I can't talk to the satellite to fly it, or I can't task my payload, it might as well not be up there. So if I can affect your communications, you don't have a satellite. Lastly, I'm going to cover PNT for the vehicle. If the vehicle doesn't know where it is, what time it is, or what way it's facing, it can't do things like face your ground station to talk to you or turn towards the sun to recharge its batteries. And if it does have that knowledge but can't correct, right, you can't do things like avoid another space object or turn towards the sun to generate power, right? So you have to know that information, and then you have to be able to act on that information. Otherwise, your satellite's at risk of being non-operable. Obviously, any threat to the space vehicle itself is a threat to the mission it's conducting, but you could also, as an attacker, go after the mission specifically, because if I can talk to my satellite and it's flying around the Earth as I expect it to, but it's not taking pictures of what I want, again, it might as well not be there. So focusing in again on position navigation and timing knowledge, if my payload does things like take pictures, but it doesn't know what time it is or where it is or what way it's facing, you might get pictures of the stars or the open ocean when you don't care about it and things like that. And again, if you don't have the ability to correct, then you don't have the ability to adjust for the knowledge you do know about. There's two kinds of payloads mainly that I'll cover as far as threats to a mission. You have sensing payloads like an imaging satellite, and although I said editing a photo to hide something is something that an attacker would likely do on the ground, I could still attack the imaging portion of a satellite by, say, limiting its ability to focus or making a geofence in its configuration so that it just doesn't take pictures over certain areas. Emitting payloads are a little more interesting, where a sensing payload, I expect to get data down from the space vehicle, right? I expect to see the photos that I've tasked up to get taken. If the satellite does something like jamming and a hacker's used arbitrary code execution to turn off the jamming but make it report that it's still on, you don't really have a good way on the ground of verifying that that's still going on. So emitting payloads kind of have a situational awareness gap for stuff like that. But there's other emitting payloads like Sirius satellite radio, right? If I was trying to attack a payload like that, I'm just going to try to alter the way it broadcasts to the ground or the signal source itself. If your satellite's not receiving radio data, it can't transmit it back down to the customers. The last thing I'll cover as far as a threat to mission but not the vehicle itself are watchdogs and safeguards. By leaving them alone, but triggering them falsely, I could put your space vehicle in a continuous loop where it's reinstalling off what it thinks is a known good operating system over and over again because it thinks it has a problem. If that's happening, you're not really going to be able to task the satellite. Or I can do things like, say, convince the satellite that it's constantly low on power so that it constantly tries to face the sun and you can't take pictures of the things you want. This isn't an all-inclusive list, but these are just some of the general ones I wanted to cover. What do I mean by threats to others? So if you have multiple ground stations and something like an imaging satellite, and you infect payload tasking files and you gain execution on the payload computer, you could then infect what look like images to get downloaded by other ground stations and affect their computers as well. So in that way, we also need to think of the fact that space vehicles can be threats to other ground stations besides the one you've attacked it through, and they can also be threats to other space vehicles. As we approach the large meshes of satellites, they're going to have ways in which they process and move data around the mesh to try to get it down to a ground station quicker, and you could potentially exploit the way that data moves around to compromise other space vehicles. The real takeaway here is that inherently space vehicle operations are trusted, right? The space vehicle trusts that what it's getting from the ground station is what it's supposed to get and vice versa. And as an attacker, I can exploit that. Vectors are the ways in which I'm going to try to introduce these attack effects I've already discussed. You have the pre-operational phase, ground stations themselves, communications, bus to payload and vice versa, and kind of what I've already talked about a little bit is the vehicle to others. So pre-operational vectors are design, development, and the supply chain. If, as a hacker, I gain access to the computer you're doing your design on, well, now I know how to attack your satellite because I know how you're going to build it. If I gain access to the computers you're doing development on, I can append malicious code to programs before they're committed to your components. If I have access to your supply chain, well, I'm sorry, but it's probably over because you can do any number of things like install hardware backdoors that cut off power to the space vehicle after 50 hours of flight, right? And there's nothing you could really do to stop that. One other thing that's a little scary for space is the supply chain, the pool of vendors for space systems is very small. Somebody had a slide up showing, I think, 3 vendors for buses, right? There's probably not that many more that are popular and widely used. So as opposed to some other systems that could maybe order their servers and laptops from any number of vendors, space has a really small pool of the skilled technology vendors that provide parts, and that means that if a nation state is trying to do supply chain interdiction against your space system, they have a much smaller footprint that they have to worry about. So I'm only going to say a couple things about the ground station. Obviously, it's computers and servers, and that's traditionally what you understand to need cybersecurity and face cyber attacks. But I think what's important to take away is currently, due to the trust between space vehicles and the ground and vice versa, the ground station itself is the last layer of defense in depth, right? If there's nothing on the satellite to be suspicious of what it's getting from the ground station, we're in a bad spot, and that's something we need to address. Also, like I said earlier, if you have a ground station and you think because it's not connected to the internet, or it's a standalone server, or it's a closed network, that you're safe from cyber attack, I encourage you to do some research on the internet and find about how all of those systems have been compromised in the past. By communications vector, I mean the denial of communications or depletion of resources due to poorly implemented communications protocol. I think this is probably one of the areas where space is actually pretty mature. What we're talking about here is if instead of listening at set intervals, you listen all the time for a ground station, I can bombard your space vehicle with hellos and try to do communication handshakes, which can either clog up your networking and prevent legitimate ground stations from talking to you, or potentially deplete resources like power. The other thing about communication as an attack vector is that there's what seems to be a widely held belief that encryption means you're safe because I have a standalone server that I operate my satellite from, and it's an encrypted link over the air. I don't really have to worry about security, but encryption really needs to be looked at as a speed bump. Eventually it will be broken, and we should have some form of contingency or planning for the day that happens because space vehicles' lifespans are increasing in duration, and so is computing power, so there is a chance that the encryption you use to communicate to your satellite today could be broken tomorrow. When I talk about bus to payload vectors and vice versa, on the space vehicle, sometimes you might have your payload computer and your flight computer are physically separate devices, but maybe they have a shared resource that they both connect to, like GPS, for instance. If I can compromise your payload computer and I can mess with your GPS, I can affect your flight computer even though I have no other way of talking to it. And the opposite is true, of course. And then there's the logical separation. There's a lot of spacecraft design where one hard drive is maybe partitioned and used by several different functions on that space vehicle. The same with memory. If I gain arbitrary code execution, I can use the fact that I'm on the same hard drive as another part of your space vehicle to attack that from the portion I have compromised. Again, I kind of covered this earlier, but whether a compromised bus or a compromised payload on a space vehicle, I can use that to go after other vehicles in a mesh. I can use that to go after other ground stations and essentially make it a pivot point from which I can launch attacks. So what does tomorrow look like for cyber and space? Onboard computing resources are going to continue to evolve, right? We're going to get more and more computing power out of less power-hungry devices, and that means that traditional security practices should become more mainstream on things like space vehicles, but again, it also means that traditional attack vectors known to more and more adversaries will become more readily available. RMF and other processes that are used to have security checklists essentially for devices, they need to adapt because currently all they do is validate and verify that you've followed the procedures and closed ports and you're communicating the way you're supposed to. There's no real exercise of the security faculties on your space vehicle. It'd be like saying, well, I torqued all the bolts on the space vehicle to spec, so I don't need to do a vibe test, right? That's essentially what is the current operating standard for cybersecurity. Additionally, with the commercialization of space, right, we have space tourism up and coming, hopefully for some companies, they think, and that means that there's going to be loss of life consequences. I think it would be the end of both the people on board and the company operating the space vehicle if a cyber attacker did something like evacuate the pressure in the space vehicle. Right? So further, I think we need to have a continued education of both the space and security industries. I think that space is currently in a place, not for you all as developers necessarily, but in general where failure happens for a lot of different reasons because space is a tough environment to operate in. And by the time cyber becomes one of the larger problems for space, it's going to be too late to address that problem. And I also, speaking as a cybersecurity professional, not a lot of us know enough about the constraints that you all code to as far as power budgets and resources to really provide security solutions that are going to work in conjunction with your code on the space vehicles that we're talking about. And so I think education on both sides is necessary. And again, by the time cyber is among the highest risks for systems in space, I think both industries need to be prepared to implement solutions for that. That's it.
Ready for questions? Questions?
So I saw you give us a bunch of kind of, this is how bad it could be. Have you seen any successful interventions so far, or are there other industries we can look at that have similarly harsh environments?
Have I seen any successful what, sorry?
Interventions.
Like stopping an attack? Or preparing for one? I think the closest analogy the space industry has is really the IoT industry and maybe even SCADA. Those have certainly blown up in cybersecurity recently over the past 5 years, and there's been a lot of attention to how do we do like lightweight security services to things like, you know, the computers that control fire alarms and sprinklers, or, you know, even in your guys' case, rotate antennas. So I would try to take lessons learned from that and how they've implemented lightweight security in those realms and try to apply it to space, if that makes sense.
So do you know, I mean, the gut reaction is that military classified missions aren't going to share their defenses because they're afraid of people discovering their vulnerabilities. But you look at the open source and the open protocols of the internet and how that has gained robustness by having red teams all the time.
Yep.
Do you think there's any interest in the military in saying, let's put these out there for people to attack and find our vulnerabilities instead of keeping it secret?
Yep, so that's a good question. I do know that at DEF CON next year in 2020, the National Security Agency, I believe, is the government organization. They plan to have a satellite that you can communicate with that they want people to go and attack. I don't know if they plan on sharing the results of that or what exactly the motivation is. But I think from the offensive cyber perspective, right, the fact that that sort of thing is happening at DEF CON means that security is starting to realize that space is blowing up and that maybe it's kind of a blind spot for us. So I hope that that increases over time.
So the analogy between space and embedded is certainly true in terms of the types of processors and constraints. The biggest difference that springs to mind offhand is that in space often there is development assurance and standards that the systems are being developed to. It's not necessarily something where it's a strict cost constraint on making the cheapest possible software. I'm wondering if the development assurance process might be a good springboard for addressing some of these attacks, or if there's ways of tweaking it to take security into mind, or if you think that's a red herring and it's fundamentally a different thing.
No, I think that especially some of the standards you guys have levied on you know, doing flight stuff with NASA and things like that, those are definitely a step in the right direction, and I agree there are things that in the IoT realm you really don't see. I'd like to think that the regulatory hoops you guys have to jump through would make sure that you don't have hard-coded credentials stored right on board the device and things like that. So I do think that there's a bit of a leg up, but I would also caution, like I said, it's not necessary that remote code execution vulnerabilities are going to be necessary to impact a space vehicle from a compromised ground station. If I can learn enough about the way you task it from the ground, right, I can abuse that to do things because assumingly you're running with some sort of mediumly privileged context to do the things you're doing on the space vehicle, if I can pass up what look like legitimate instructions that I think are going to affect it, I can still attack it that way.
Yes. So even in the non-space arena, hello? Oh. Even in the non-space arena, there's often a spirit of non-sharing with the idea of proprietary software and hardware. And this does apply in this situation as well. What do you think that companies, not just the government, could do to try to promote a more open kind of collaboration in the spirit of security enhancements?
I think space is probably already kind of along the path to solving that issue because you're moving towards more standardized implementations of things. As you adopt stuff like Linux operating systems, instead of writing one-off pieces of real-time operating software, you're creating a bigger community to contribute to those things. I do understand that there is that proprietary issue and that companies might try to not disclose, just as the government might not, as was mentioned by the gentleman over here, but I think space is on the way to getting there.
So you mentioned earlier that Linux is actually potentially a big attack vector because the hackers know it quite well. Would you say that it would be safer to run like a BSD distribution instead of a Linux distribution, or would that not necessarily make things safer? No.
No, I mean, I apologize for using Linux to describe any sort of normal operating system, but the takeaway there is that as you as developers use things that are more like normal computers, your systems are going to be, you know, to me it's going to look like just another computer out there, right? If I'm riding SpaceWire, but I still get to talk TCP/IP, and it still has Linuxy things or Unixy things on it, then I know how to interact with that device.
Great, thank you.